gives me 16 times 3 to the first power is just 3, all over 1 to the fifth is just 1. So right now I have 16 times 3, all of that over 1. Whenever a number is over 1, we can just write it as the numerator, so all we have to worry about is 16 times 3. 6 times 3 gives me 18. 3 times 1 plus 4, 48. So my answer in this case is going to be 48. Example number 5. I have 5 squared times 5 to the 0 power times 5 to the negative 4th. So, like I said before, I'm not even going to worry about those negative exponents yet. First, I'm just going to multiply and combine my exponents. So all of my bases in this case are the same. So I'm going to keep my base. And since I'm multiplying, I add those exponents. So I'm going to have 2 plus 0 minus 4. That's going to be my new exponent. So it's going to be 5 to the 2 plus 0 gives me 2, so 2 minus 4, which is going to be 5. 2 minus 4 is negative 2. Now I can worry about simplifying with that negative exponent. Because the exponent is negative, I need to take the reciprocal. So my answer is going to be 1 over 5 squared, because since I moved it, now the exponent becomes positive, and we can evaluate this as well. 1 over 5 squared actually gives me 1 over 25. So I can leave my answer as that, and I am finished. Example number 6 is a little bit trickier because it's just a tad longer. So what we're going to do in this case, the first thing that I'm going to do is I'm going to simplify as much as I can inside this set of parentheses. So I notice that I have inside the parentheses a 3 and a negative 6. And since those are both constants, we can actually simplify that. 3 goes into 3 once, and 3 goes into negative 6 negative 2 times. So now the coefficient on top is just 1, so I'm not even going to write it. And on the bottom, I have negative 2. Now up here, I have x to the 5th and x to the 6th. So that's going to become x. And since I'm dividing to the 5 minus 6. And the same thing with my y's. My y's, I have y. This is y to the 1. So y to the 1 minus 3. All of that is raised to the power of negative 2. So I'm going to keep going. X to the 5 minus 6 is the x to the negative first power times y. 1 minus 3 is negative 2. All of that over negative 2. And all of that to the power of negative 2. Now normally we might want to move that x and y to the denominator because they're negative, but I know that when I distribute this negative 2 power, it's actually going to make both of them positive. So I'm just going to keep going. So I distribute that power of negative 2 to everything inside the parentheses, and in my numerator I'm going to get x to the negative 1 times negative 2, y to the negative 2 times negative 2. And in my denominator, I have negative 2, and we need to keep it in parentheses, to the negative second power. So once all of that simplifies, I get x to the second power, y to the fourth power, and now I have negative 2 to the negative second power, so I need to move it up to the numerator. So it's actually going to become negative 2 squared. And I started to run out of room there. So negative 2 squared gives me negative 2 times negative 2, which is actually positive 4. So my coefficient is going to be positive 4, x squared, y to the 4th. Now everything has a positive exponent, and we can leave our answer. For example number 7, we have 4t times s to the negative 1st power, t to the negative 3rd power, and all of that raised to the negative 2nd power. It might look like we want to do distributive property first here, but we still have to follow order of operations, and in order of operations, exponents comes before multiplication. So I'm going to take that negative 2 exponent and distribute it inside the parentheses. So I'm going to get 4t times s to the negative 1 times negative 2, because we have to multiply those exponents, t to the negative 3 times negative 2. And we're going to keep evaluating those exponents before we distribute. So I have 4t times s to the negative 1 times negative 2 gives me s squared, and t to the negative 3 times negative 2 gives me t to the 6th power. So now I have 4t times s squared t to the 6th. So when I multiply these, I can combine the bases t and t. This t is to a power of 1. So when we multiply, we're just going to rewrite our coefficient first, s squared, because nothing can combine with the s squared. There's no other bases of s. And then t to the 1 plus 6. So that simplifies to 4s squared t to the 7th. Everything has a positive exponent, so that is our answer. In example number 8, we are first in this case going to evaluate this negative exponent, because that's going to make everything a lot easier when we start multiplying. So what I have, because x is raised to the negative 3rd, I have to move it down to make it positive. So on the numerator is just going to be a 1, and then we will have x to the 3rd y squared times 1 over xy. Now it's just multiplying fractions, so I can multiply my numerators. 1 times 1 is just 1. In the denominator, I have an x to the 3rd and an x to the 1st power, so that's going to be x to the 3 plus 1. And I have y squared and y to the 1st power, so that's going to be y to the 2 plus 1. So when I simplify that, I'm going to get 1 over x to the 4th, y to the 3rd. Everything is positive, so our answer is just left as that. And finally, example number 9. We have this quantity, 6c to the 4th, f to the negative 3rd, all of that to the negative 1st power, times 3c to the negative 3rd, f to the 3rd, all of that to the 2nd power. In this case, I'm going to distribute those exponents first, because it's going to make things a little simpler for me. So what I have after I distribute is I'm going to get 6 to the negative 1st power, c to the 4 times negative 1st power, f to the negative 3rd times negative 1st power, all of that over 3 squared, c to the negative 3rd times 2, f to the 3rd times 2. Now let's evaluate that and do some multiplication. 6 to the negative 1st just stays the same. c to the 4 times negative 1 becomes c to the negative 4. F to the negative 3 times negative 1 becomes f to the third. All of that is over 3 squared. We can actually simplify that to 9. C to the negative 3 times 2 gives me c to the negative 6. And f to the positive 6. So now we have some negative exponents that we probably want to move around first. So I'm going to move this 6 to the negative 1 down to the denominator. C to the negative 4 also moves down, but c to the negative 6 moves up. So let's rewrite it all first, and then we'll start simplifying. So in the numerator, now I have c to the 6, because it became positive when we moved it. F to the third. All of that over 6 times 9, which gives me 54. C to the fourth, which moved down. F to the 6. So now I'm just going to worry about combining the c's and the f's. So I'm going to have in the numerator c to the 6 minus 4, f to the 3 minus 6, all of that over 54. Which equals c to the 6 minus 4 is c squared. F to the 3 minus 6 gives me f to the negative third, all of that over 54. And then we can finally move that f to the negative third back down to the denominator. So we're going to get c squared, all of that over 54 f to the third. Everything is finally positive, so this is our final answer.